Good morning. My name is Charlie Baum, and today we're going to continue with our discussion on efficiency. Today's discussion is going to look at the impact of taxes. Taxes are one of the most important methods by which the government is able to raise revenue in order to fund their activities. Taxes can either be percentage taxes, which would be a percent tax on the amount of a sale, or they can be per unit taxes. An example of a per unit tax would be the 18.4-cent tax that the federal government charges on each gallon of gasoline. Let's look at a market and the effect of a tax in this market. We're looking at the market for cigarettes. Let's suppose that before any taxes are added, the equilibrium price is $5 per pack of cigarettes and the equilibrium quantity is 4 billion packs of cigarettes per year. If we add a tax to this market, then it will affect the curve for which the party pays the tax. For example, let's suppose that we add a $1 tax on each pack of cigarettes to be paid for by producers. This will shift the supply curve up by an amount equal to the size of the tax. If the tax is $1 and if producers are the ones required to pay the tax to the government, then this will shift the supply curve up by $1. If the tax had been paid for by consumers to the government, then this would have shifted the demand curve down by an amount equal to the size of the tax. When the supply curve shifts up by an amount equal to the size of the tax, when it shifts up by $1, the new intersection point representing the new equilibrium is going to be at point B. Here the equilibrium price is $5.90 and the equilibrium quantity is 3.7 billion packs of cigarettes per year. This is the price and quantity at which the original demand curve intersects the new supply curve that reflects the tax. So with the tax, the equilibrium price of cigarettes goes up from $5 to $5.90, and the equilibrium quantity goes down from from 4 billion packs per year to 3.7 billion packs per year. Let's talk just a little bit more about why the supply curve shifts up by $1. If firms were willing to sell 4 billion packs of cigarettes at a price of $5 before the tax, as illustrated by point A, then with the $1 tax, these producers would need exactly $1 more in order to continue to be willing to supply 4 billion packs of cigarettes per year. That's because once the $1 tax is subtracted from the price, what producers are left with is $5. So the $1 tax shifts the supply curve up by $1. So the point immediately above point A would be $6, so that if the producers receive a price of $6 and then pay a $1 tax to the government, what they're left with is $5, and that's what the original demand curve, supply curve said producers must receive in order to be willing to supply 4 billion packs of cigarettes to the marketplace. Essentially, the tax, the per unit tax, raises the marginal cost of cigarettes. And so it shifts the supply curve up by that amount to indicate that producers must receive that much more now with the tax in order to be willing to continue to supply the same quantity. Nevertheless, the new equilibrium price is not $6 per pack, and that's because when the price goes up, the quantity demanded by consumers goes down. The new equilibrium, the new intersection point, is not quite $1 higher. It's 90 cents higher. Now let's look at the effect of the tax on economic surplus. Before the tax, the equilibrium price was $5, and so consumers had surplus equal to the area under the demand curve and above the price level, and producers had surplus equal to the area under the price level and above the supply curve. Now, with the tax, The new equilibrium price for consumers is $5.90, and so consumer surplus now is the area under the demand curve and above this higher price level. So consumers are going to lose this area that had been under the demand curve and above the original $5 price level. At the same time, producers get the $5.90 price level in the marketplace. They pay the $1 tax to the government and are left with $4.90. So producer surplus is the area under the price level, under the amount that producers get to keep after paying the tax, and above the supply curve. The result is that producer surplus has gone down. It's decreased by an amount equal to the area between the original price and the new amount that producers get to keep with the tax. So the result of all this is that deadweight loss is created. The deadweight loss that's created is the lost economic surplus. It's equal to the area under the demand curve and above the supply curve for packs of cigarettes that had been supplied to the market and consumed in the market that are no longer consumed and supplied. It's equal to the yellow area in this graph. The green area is also an area that used to be either consumer surplus or producer surplus, but this area is no longer surplus anymore. But it's not deadweight loss because this represents tax revenue, which is a real resource for the government. It's not deadweight loss because the tax revenue presumably will be redistributed back from the government to provide goods and service to provide government services in the economy. So the green box represents tax revenue, and it equals the size of the tax, which is $1. It's the vertical distance here, multiplied by the number of packs of cigarettes that are taxed, which is 3.7 million. If you multiplied 3.7 million packs of cigarettes by the $1 tax, you would get an area that's equal to the green rectangle, and that represents the new tax revenue. Okay, let's look at a tax on gasoline. Initially, the market price is $3.50 and the equilibrium quantity is 44 billion gallons per year. Then if we add a 10-cent tax per gallon, this will shift the supply curve up by 10 cents. It will shift the supply curve up vertically by an amount equal to the size of the tax. The new equilibrium quantity and price will be where the original demand curve intersects the new supply curve with the tax. This will be at a price of $3.50, and the new equilibrium quantity will be 144 gallons per year. Before the tax, consumers paid a price of $3.50. With the tax, consumers pay a price of $3.58. So consumers are paying 8 cents of the 10-cent tax. That's 80% of the tax. And producers receive a price of $3.58 in the market, and then they pay the 10-cent tax to the government, and what they're left with is $3.48. Before the tax, producers collected a price of $3.50. With the 10-cent tax, they collect a price of $3.58, pay the 10-cent tax to the government, and are left with $3.48. So producers essentially pay 2 cents of the 10-cent tax in the form of being able to keep a smaller amount. Tax incidence indicates who bears the real burden of the tax. Even though one group may physically send the tax to the government, the burden of the tax may be distributed differently. In our prior example, the 10-cent gasoline tax was physically paid to the government by producers, but consumers effectively paid 80% of the tax. They bore 80% of the tax burden in the form of a higher market price, and producers paid the remaining 20 cents of the tax. They bore the remaining 20% burden of the tax. We could have taxed consumers. The equilibrium price in this diagram is again $3.50, and the equilibrium quantity is 144 billion gallons of gasoline per year. If we tax consumers, then this will shift the demand curve down by an amount equal to the tax. So the demand curve will shift down by 10 cents. The new equilibrium price will be $3.48. Once consumers pay the tax to the government, the total cost to them will be 10 cents more. It'll be $3.58. So in this example, we see that if we tax consumers, we end up with a lower market price level, but consumers are passing a portion of the tax burden along to producers in the form of lower market prices. So the tax burden for consumers is 80% of the tax, because the total cost to consumers with the tax is $3.58. It used to be $3.50, so consumers are again paying 8 cents out of the 10-cent tax. And even though producers are not physically paying the tax to the government, they bear 20% of the tax burden, because the amount that they keep after the tax is $3.48. That's the new equilibrium price level, and the price before the tax had been $3.50. So producers bear 20% of the tax burden. This shows that it doesn't really matter whether producers physically pay the tax to the government or consumers physically pay the tax to the government. The tax burden is distributed between the two parties the same. Tax incidence is essentially determined by how steep the curves are. If one of the groups, either consumers or producers, has a relatively steep curve, then they will pay a relatively large portion of the tax incidence, because the steep curve indicates that that group is not particularly sensitive to prices. Just the opposite, if one of the two groups has a relatively flat curve, then they will pay a relatively small portion of the tax burden, and that's because a flat curve suggests that that group is relatively sensitive to price changes.